Okay, so in this video today we're going to be looking at what's known as the identity matrix, okay, which is our fourth video in the matrix chapter. Okay, so what's known as the identity matrix. Okay, so identity matrices happen in the square type, so you get a 2 by 2, 3 by 3, 4 by 4. Okay, and you'll see there's a nice consistent pattern with them. So we'll look at the 2 by 2 case first. So the 2 by 2 identity matrix we'll denote it as I. What it looks like is 1, 0, 0, 1. Okay, that's what's known as the identity matrix for the 2 by 2 case. Okay, so it's known as the 2 by 2 identity matrix. Okay. Now, it does have a special property, okay, which we'll now look at as well. So, it has a special property. And we'll look at an example to show what those properties are. Okay, so let's take a matrix A to be a general 2 by 2 matrix. So let's say we've got values A, B, C, and D in matrix A. Okay, so it's a general 2 by 2 matrix. Okay, and what we're going to do with it, okay, well, we're going to multiply A with the identity matrix. Okay, so A times I, well, that would be A, B, C, D multiplied by the identity matrix for 2 by 2, 1, 0, 0, 1. Okay, now if I was to multiply this out, which we've done in the previous couple of videos, we're looking at multiplying matrices. So we do a row times a column. Okay, so I would get A plus 0B in the first entry. Then I would get first row in the second column, so that would be 0A plus B. Second row, that's just C and D, so C times 1 is C plus 0D. And then 0C plus 1D. Okay, so I've got those values there. And if I simplify them, well, A plus 0B is just A, 0A plus B is just B, C plus 0D is just C, and 0C plus D is just D. And you can see I end up with my matrix A again. Okay, I get the exact. So remember, that's going to happen for every 2 by 2 matrix because that was just the general case. Okay, so no matter what letters you get, you always get the same matrix back. Okay, also, okay, what we'll now do is we'll now do I times A, because we know matrix multiplication isn't commutative, it doesn't work all the time for when you switch the matrices around. So let's see if it works for this here. So that's going to be 1, 0, 0, 1 multiplied by A, B, C, D. That's going to give me A plus 0C. Then the next one's going to be B plus 0D. Second row into the columns, so that's 0A plus C, and then 0B plus D. And again, if you simplify, you end up with A, B, C, and D, which again is your matrix A. Okay, so what we've just shown there is that it does have a very special property. So A times I equals A, and I times A equals A for any 2 by 2 matrix. Any 2 by 2 matrix A. Okay, therefore I behaves in matrix multiplication. Oh, got our matrix, let's put that in. Matrix multiplication like 1, the number 1, behaves in multiplication of real numbers. Okay, so obviously with a real number, if you times it by 1, you get the same thing back. Or if you times a matrix by the identity matrix, you keep the same matrix. Okay, so that's what that last statement says. Okay, so that's the good property about identity matrix. Okay, if you multiply it by something, it stays the same. Okay, the matrix that you multiply it with stays the same. Okay, what we'll do is we'll look at how some of these questions can get asked. Okay, so example 1, let A now be the matrix -2, 0, 4, -1. Okay, and we're going to find the values of P and Q for which A squared equals P times A plus Q times I. Okay, so our job is to find the values of P and Q would mean that A squared would equal P times the value A plus Q times the identity matrix I. Okay, and then there's also going to be hence. Okay, part A. So after we do that, hence express A cubed as a combination of A and I. Okay. So after we've done the first part, we're then asked to express A cubed as a combination of A and I. And then part B, find the matrix B such that A times B would give us our identity matrix. Okay, so there's quite a few bits in that question. Okay, so we want to find values P and Q for which A squared would be P times A plus Q times I first, and then after that, can we then express A cubed in a similar fashion? And then part B, can we find the matrix P such that if we multiplied it by A, we would get the identity matrix back? Okay, so let's have a look at how we would go along doing that there. Okay, so let's start with the first thing. I need to get a value for A squared. Okay, so let's see what A squared is. So A squared would be, so that's solution now, sorry. Solution, A squared is A times A, which means I'm doing a matrix multiplication of A, which is -2, 0, 4, -1. I need to multiply -2, 0, 4, -1. Okay, so that's the matrix multiplication there. So remember, we need to do multiplication like that. We can't just square the actual numbers in our matrix, okay? So, first row times the first column. Okay, so we'll have -2 times -2. Okay, plus 0 lots of 4, well that just was 0, so that's just what I'm going to get there. Okay, next row, first row times the second column, so -2 times 0, that's 0. Then I'm going to add 0 times -1, that's also 0, so that's just 0 there. Okay, then I'm going to do second row times the column, so 4 times -2. And then I'm going to add -1 times 4. Okay, maybe not give myself tons of space here. Let's see if I can fix that a bit. There we are. Put that back on in a second. And then second row with the second column, so 4 times 0 is 0, -1 times -1 is just 1. Okay, don't have plenty of space. Okay, tidy up my answers. -2 times -2 is 4, 0. Then I've got 4 times -2 which is negative 8, plus negative 1 times negative 4, which is negative 12, and 1. Okay, so that's what a squared is there. Alright, now what we're told, okay, is that equals, we're told that a squared equals value p times a plus the value q times I. So let's see if we can write that in a way. So that means that we know 4, which is a squared, 4, 0, negative 12, 1. Well, it equals a value p that multiplies the matrix A. Matrix A is negative 2, 0, 4, negative 1. Plus a value q which would give me the identity matrix with that there. Okay. So what we're going to do is we're going to fix this sort of right hand side and then we're going to compare sort of coefficients, okay, a bit like how we've done it this year in the course already. So if I look at my entries, okay, so if I look at my first entry, well, negative 2 is going to have to multiply p, so that's going to be negative 2p plus 1 times q, that's just q. So that's what my first entry looks like, okay. So I've got negative 2p plus the q, that gives me my first entry, okay. And I know my first entry for a squared was 4. Okay, right, second entry, p times 0, that's 0, plus q times 0, well, that's just 0. So my second entry is just 0. Okay, next one, okay, so bottom left hand corner, p times 4 is 4p, plus 0 lots of q, that's just 4p. Okay, and lastly, I've got negative 1 times p, which is negative p, plus a q, so that's negative p plus q. Okay, so what we've actually got is we've actually got 4 equations from here. Okay, from our 4 entries. Okay, so from equation 1, negative 2p plus q, well, that equals my first entry in my a squared matrix, which was 4. Okay, equation 2, well, it's telling me 0 equals 0. It's not really giving us any information there. It's correct, but it's just not giving us any indication about anything. Equation 3, 4p equals negative 12, and 4 would be negative p plus q, that's got to equal 1. So we've got 4 equations that we're our job to try and find the values of p and q. Normally what happens is, well, you could use simultaneous equations with like equation 1 and equation 4, for example, but normally one of the equations gives you a clue about one of them first. Okay, so if I actually look at equation 3, it's telling me 4p equals negative 12, therefore my p value was negative 3. Okay, so I found the value that gives me that there. Then I can either use equation 1 or equation 4 after that, but if I go to equation 4, that's probably the easiest. Negative p plus q equals 1, therefore that's negative 3 plus q equals 1, therefore that will solve to q equals negative 2. Okay, so those are my values there, therefore a squared would equal, well, it was p times a, which is negative 3 lots of a, minus 2 lots of the identity matrix. Okay, so I found my 2 values for p and q. Any questions at this point here, folks? No? We okay? Right, now let's see if we can then solve the hence part. So hence part A asked us, can we write a cubed in this form? So it's asking us to basically, when it says hence, use what we've just done there. They're not asking us to multiply, because we could find a cubed by multiplying a squared times a. Okay, minus multiplication. But they're asking us to see if we can get it in terms of a and I, and that would take a bit longer process to try and can get new values. Okay, so but I do know that a cubed, well, that is a times a squared. Yeah, but I know what a squared is. A squared, well, that's negative 3 lots of a minus 2 lots of I. Okay, that's what a squared gives me. So if I multiply this out, that would give me negative 3 lots of a squared minus two lots of A times I. But we know from identity matrix that A times I just gives me back my matrix A. So I can simplify that down to negative 3A squared minus two lots of A. Okay, so that I can basically almost drop off. Alright, because multiplying the A. So I'm not quite there yet, but I can now substitute back in an A squared. Okay, because I've got an A squared back out, so I can then put in what I got for A squared back in, so that's negative 3 multiplied by A squared, which is negative 3 lots of A minus 2I minus 2A. That would give me 9A plus 6I minus 2A. So that would equal 7A plus 6I. Okay, so that's me how I can write down the values of. I've got A cubed in the form of A and I. Are you okay with that step? Yeah. So basically, just algebra, bit of matrix multiplication, property usage. Sorry, I should say, to help simplify that down. Okay. All right. And then there was a part B. Part B asked us, can we find the matrix B such that B times A would equal the identity matrix? Because this bit's a bit trickier. Okay. So what I know is, I knew from the first part, I did say hence as well, A squared. Well, if I rearrange, well, that is negative 3A minus 2I. Okay. So if I rearrange this, in other words, if I bring the A's over, okay, that means I'm going to have A squared plus 3A equals minus 2I. Yeah, because remember, what I'm trying to achieve here is this. I'm trying to achieve A times B equals I. That's not right. Okay, that's what I'm trying to achieve here. Okay, in fact, what is that there? Yeah, that's right. Okay, A times B equals I. So, okay, now I still want to get I on this right hand side though, so I'm going to divide everything by 2, but when it's matrices, it's the same as taking negative a half of the matrix. Okay, so that's going to be negative a half of A squared plus 3A equals, not 2I, just I now. Okay, so I want it to still look like A times B though, so I need to get my matrix A out, so I'm going to take a common factor of A out. So I've got the minus a half A plus 3 equals I. Oh, I made a mistake there, let me rub that out actually. Factorise it as if it was just normal algebra here, it's not quite as matrices, I've got to be careful. So if I take A out, well, I'm left with A there, but I still need to make this part look like a matrix, therefore the way to do it is 3I now. Okay, so that's now a matrix, but if I just left 3, it could just be a number. Okay, and that equals I there. Okay, so what that's telling me is A times something, which is my B matrix, has to give me an identity matrix. Therefore, that B has to be negative a half of A plus 3I. Okay, because that's what is multiplying the A to give me the identity matrix. Okay, that's everything else apart from that A there. Okay, and I can work this out now. Okay, so I'll put it over here so we've got the space here. So B is going to be negative a half of the matrix A. The matrix A was negative 2, 0, 4, minus 1, plus 3 lots of the identity matrix, which is 3 lots of 1, 0, 0, 1. Okay, and if I tidy this up, that's going to be negative a half of, okay, well, negative 2 plus 3 lots of 1 is just 1. That's just going to give me 0 in the second coefficient of that first row. 4 plus 3 lots of 0 is just 4. And negative 1 plus 3 lots of 1 is 2. Okay, and if I take negative a half of those things there, that gives me the matrix negative a half, 0, negative 2, negative 1. Okay, so that's what the matrix B must have been there. Okay, and if you want to check that, if you times the matrix A with that matrix B, you should get the identity matrix back out. Okay, that's a way you can double check that there. You got any questions on that at all, folks? No? Okay.